All right, Algebra 2. Welcome back, guys. Here we go. We are in section 3 today, all about ellipses. Okay, so we're getting into, yes, unfortunately, still some more shapes. And yes, I understand that might make you think about geometry. And yes, I understand that that might bring back some bad memories. So my apologies there. All right. But trust me, there's plenty of calculations and algebra to be done. So I don't know if that makes you feel any better, but in my opinion, there's not a ton of connections to geometry. You just are looking at shapes. So there you go. All right, forget all that junk. Let's get into it. So here we go. Ellipses. This is the shape we're dealing with. Okay, so the ellipse right here, right here. Basically, what we're talking about, you have a circle, but it's kind of being pushed in on the sides, which if it's being pushed in on the sides, then that means you're actually dealing with a vertical ellipse. If you have an ellipse that's being pushed in on the top and the bottom, then that's going to actually give you one of these guys over here. That's the horizontal ellipse. So horizontal meaning it's like stretching on the sides, vertical ellipse meaning it's stretching on the top and bottom. Okay, so whatever form of a kind of a reminder you want to put out there for yourself to help you remember, is it vertical, is it horizontal? Figure that part out. All right, the ellipse set of points though, you're going to be using this distance formula still. All right, you're going to be given fixed points, which are going to be shorthand of F1 and F2, meaning shorthand like they were not going to say fixed points. They're probably just going to say F1, here it is, F2, here it is. And then you're going to have a given point right here, which they will also be describing to you. Okay. And when this is the situation and you're trying to calculate, as it says, the constant sum of an ellipse, then basically what we're doing is you're going to calculate the distance from the point to F1, then the distance from the point to F2, and then you're going to be adding those two distances together to give you this constant sum of an ellipse. All right. This is going to be our first example problem. We're going to do one of these where you have a point, F1, calculate distance. Same point, but now F2, calculate the distance, and then add those two together. Okay, so that's the basics of what you're going to be dealing with in terms of how to calculate the constant sum of an ellipse. Now comes this chart right here. All right, and I understand that sometimes you guys are like, listen, what do you really want me to copy out of this chart? Unfortunately, all of it. All right, so for this one, you need all of it, and including this part up here. All right, so in an example problem, we're going to be using this little equation. Also, we're going to have access to that one and that one, and it all depends on what's given. Maybe you're going to be given the vertices, so you're focusing on this or this. It depends if the vertice given has a 0 for the y value or a 0 for the x value. All right, that plays into which one are we going to use, the horizontal or the vertical. All right, so follow the example problem where they're asking us to calculate, or actually write the standard form of the equation. And like I said, we will be using this little equation right here one time. Then that gets us down to here, where again, I know you hate it, but you're going to need to copy it all. I will tell you though that I'm going to teach you a more direct method than the book would use. So if you're looking at the book on how to calculate standard form when your center is not at 0, 0, all right, that's what we're talking about here. If the center is not at 0, 0, there's a very direct method that we could use to kind of help calculate the standard form, and especially when we're graphing it. That's a lot simpler. I'm going to just get right to the point with that one. Okay. So speaking of getting right to the point, let's do that. Let's do some example problems. All right. So first example problem, we're going to be doing the distance formula. All right. So find the constant sum of an ellipse. There's F1, there's F2, and then there's the given point. All right. Well, the given point, that's actually going to represent our X1 and our Y1. Then remember, you're going to have to calculate two distances. So the first distance is going to go with the F1, which is going to represent our x2 and our y2. Then you're going to have another distance, but this is going to be with the F2. So this is our other x2 and y2. So I just put it in different colors to make sure you understood. We're going to do two distances. I know they're both saying x2, y2, but just kind of follow a little bit on the fact that one's red, one's black, different color. So we're going to use them in different situations here. All right, so let's set up the distance formula for the point with F1. Okay, all right, so now we just need to fill in the blanks. We have our x2, which is 0, minus our x1, which is also 0. So that's nice. 0 minus 0. Then we have our our y2, which is a negative 8 minus 10. Minus 10. Wanted to make sure that wasn't a negative 10. Okay, and then we're going to be adding that solution that we get to now our second distance formula. And let's get this one set up. Okay, so we're going to use the F2 point now. And so you have the x2 minus the x1. Again, both are zeros. All right, so that's nice. Then you have 8 minus 10. Okay. All right, so now we're just looking at doing our calculations. You got 0 minus 0, so that one works out easily. A negative 8 minus 10, but then you're squaring it. So that right there is going to give you, what, a negative 18. And then 18 squared gives you 324. And then you're going to take the square root of 324, which then is basically just going backwards to 18. So this one works out to be 18 plus. All right, 0 minus 0, that one's good. 8 minus 10, that one's going to give you a negative 2. You square it. That's going to give you 4. Take the square root of that. That's going to get you back to 2. All are positives. Remember that, because when you square it, you're immediately creating a positive, and then you're allowed to then take that square root, which brings you back to a positive, but just the smaller value. So 18 plus 2, this is going to give us 20. So that right there is our solution. So when they say find the constant sum of the ellipse, for us in this problem, it's 20. All right, so remember, distance from point to F1, distance from point to F2, add those two distances together. That's going to be your constant sum. All right, so that's the first example problem. Let's do the second one here. So we're looking at the standard form of an ellipse, but this one has a center at 0, 0. Okay, so you're going to want to use the chart in your notes where it says center at 0, 0. All right, so that's the kind of the helpful chart for us right here. All right, let's zoom in on number 2. We have the vertex at 9, the co-vertex at 0, 5. And what you should do is in the chart, if you look at when the vertex is given with 0 is the y value, which this is what we're looking at here. The vertex is given and 0 is the y value. Look in the chart. That follows a horizontal equation in standard form. Okay, so again, if you look at the chart, let's see, this is the chart we're talking about. This is what I mean. The vertex is given as 9, 0. All right, so you see how we're looking at, again, zeros here. Then that means we are dealing with a horizontal equation, which means our equation is going to look very similar to that. Okay, And you'll notice the x squared and the y squared and the equals 1, that's all given as a part of the equation. So that's really nice. Let's go ahead and put that in part of our answer already. X squared over something we'll figure out, plus y squared, again, over something we're going to be figuring out, equals 1. Okay, that's all given as a part of the equation once we figure out, okay, great, we're using horizontal. Now we got to go one step further. And again, look at that chart. Vertex with the y that's 0. We take the a value, which is 9, and we are going to be squaring the a value. Notice, look at the equation. X squared over a squared. A is 9. Square it. We're looking at 81 right there. Okay. Look at the co-vertex. That is our b value, and this fits perfectly again because in the horizontal part of the chart, your x value should be 0. And if you look back at the chart for the co-vertex, the x value is 0. The b value is the other point right here, which is 5. Square that, and you get 25. This is the equation they are looking for. That's the equation in standard form for a horizontal ellipse. Okay, let's take a look at number 3, because this one is where this little equation of c squared equals a squared minus b squared is going to come in quite handy. Okay, so here's why. The co-vertex is given, and the co-vertex goes with your b value, but the focus goes with your c value right here. But you'll notice that in the horizontal and vertical form of the equation, there is no c value that's a part of the equation. So that means we're going to have to use the a value, use the c value, and calculate the b value. All right, so let's do that as step 1. So if we're given the c value, all right, which if you look, this is going to be a vertical form of the equation. So actually, real quick, let's just start that. And how do I know that this is a vertical form of the equation? Let's look at the co-vertex. Your y value is 0. Look at the chart under co-vertex. B comma 0 right there is with the vertical column. Okay, so now let's go back and use this equation. So our c value, c squared is 9. There we go, 9. And then our co-vertex, we don't know a, but our co-vertex for b, which is given as 4, we square that, that's minus 16. Solve for a squared. That means you're going to have to add 16, and you're going to get 25 equals a squared. Okay, well, if you look at the equation, they want the value of a squared. So you don't actually have to calculate the square root. They want a squared, and that, in fact, is what we were calculating for. 25 is a squared. So let's go ahead and plug in our values. Or the a squared is 25. That goes right here. And the b squared, which we already had in the co-vertex, was given as 4. That's going to be 16. And that is our equation right there. Okay? And again, if you have questions, get all this written down, all of it in your notes written down, and then bring those questions to class. All right, let's address it. Let's make sure we understand this, and then we're comfortable to move on. All right, but don't ask the question. You won't get the answer, and it's going to be a struggle. Okay, so let's make sure that we are asking those questions. All right, now here we go. Numbers 4 and numbers 5 are graphing problems. But here's the issue. You can't just plug this into the calculator because you have x and y on the same side, and you're dealing with division and exponents and all that. I'm going to give you the direct, easy, quick method without even needing the graphing calculator to graph these. And yes, when you watch this video, you will be graphing on your homework. All right, so here we go. So here is the quick, direct method to graphing ellipses. All right, step one, look at the numerator. Do you notice how in the numerator, all you're given is x squared and y squared? It doesn't look like this one over here where you're dealing with an x minus 2 and an x minus 4. So if all you have is an x squared and a y squared in your numerator, your center of the ellipse is at 0, 0. Perfect. So right there, I know where my center is. Now what you're going to be doing is calculating the distance from the center on the x-axis and the distance from the center on the y-axis. And here's the quick way to do that. X squared, the number below it means I go with x. What's the square root of 64? Square root of 64 is 8. That means we are going to have a plus and minus 8 from the center on the x-axis. So if we go ahead and label all of these guys as, like, each line counts as 2, and we're going to go 2, 4, 6, 8. Boom, right there. 2, 4, 6, 8. Boom, right there. Okay, now we need to calculate the vertical, the y-axis, and all we have to do is know, okay, this side has the y. That means that this is going to tell me the distance from the center. What's the square root of 25? 5. So we're talking about a plus or minus 5 from the center. And again, if we wanted to stick with the whole, let's just use every line as it is 2. Then we're going to go 2, 4, 5 is right there in the middle. And 2, 4, 5 is right there in the middle. All right, this is going to make our ellipse. And I'm going to attempt to connect all of these points and see if Mr. iPad here can help bring that perfect. All right, good enough. There we go. That is our ellipse. Quick, direct, easy way to graph it. All right, let's do it again. But now what if you have values with x and y? Then those become your new center values. If this says minus 2, really think of it as this is positive 2. If this says minus 4, think of it as really that is a positive 4. And right there, guys, we just created our center. Our center is actually at 2, 4. So that's step one. Figure out what the center is. All right. So let's go right 2, up 4. That is our center right there. That is 2, 4. Every other value is based off of its distance from that center point. So again, let's go ahead and remember, x is here. X square root of 25 is our distance on the x-axis. So this right here gives me a plus and minus 5. This right here gives me a plus and minus 3 on the y-axis. Okay, so that means we're going to go down 1, 2, 3. We're going to go up 1, 2, 3. That's our y-axis. The x-axis is 5. I don't think I'm going to be able to fit it in here perfectly. So we got 1, 2, 3, 4. Yeah, let's imagine that that's really 5. And 1, 2, 3, 4, 5. That would be right about there. Okay, again, I know that this is not creating a perfect ellipse because I didn't give myself enough space. So with that being said, I think you get the process, hopefully, or at least rewatch this part of the video and then get the process. Okay, let's connect these. And again, I know it's not making a perfect ellipse because I just didn't leave enough space, but we're good. All right, so let's go ahead and zoom out. There are example problems 2 through 5. All right, worked out right there for you. And then right there, example problem 1 works out there for you. This is section 3, okay? So keep working hard, write down those questions, ask those questions. I'll see you guys in the next one.